Yeah, so you remember that in the last class we have been discussing gradient, vector gradient. We have a scalar field phi, and once we have a scalar field means there is a region of the space, and at each point on that region a scalar function is uniquely defined. So that is the definition of scalar field, and we are considering a scalar field phi xyz, and which is defined in a region R. And within that region, we are considering two different points P and P dash, and through which two level surfaces. One of which the value of phi is taken to be phi, and in the nearby level surface, the value of phi is equal to phi plus delta phi. And in the last class, okay, so we have defined different points, and in particular this angle. So what is this point M? This is the perpendicular foot of the perpendicular drawn from the point P of the surface S. This is the surface S to the other surface. And we assume that since these two level surfaces cannot intersect, we assume that this angle P M P dash is 90 degree. Okay, and this will be valid. Someone of you rightly pointed out that we cannot allow large value of theta. In that case, theta should be also very small, and then this approximation that this angle PMP dash is 90 degree will be valid. And we also assume that this vector PP dash is equal to delta R, thick delta R, which is equal to delta S into A vector, A cap, that is. A cap is the unit vector in the direction of PP dash. And moreover, we have introduced the notation delta N cap. N cap is not visible. Let me just add that N cap. Yeah. So this N cap is the unit vector in the normal direction. This one is N cap. And delta N is the magnitude of PM. And now if we consider this triangle PP dash M, then you can easily see that this delta, this relation basically, yeah, delta N is equal to delta S cos theta. So from that triangle, so from this triangle PP dash M, we can easily get this delta N is equal to delta S cos theta. Yes. So can you please mute yourself? Someone of you are talking. Yeah, so this is quite clear that delta n, that is the normal component, magnitude of the normal vector PM is equal to delta S cos theta. In fact, delta n by delta S is equal to cos theta, therefore delta n is equal to delta S cos theta. And then rate of change of phi, as we are moving from one level surface to another nearby level surface, phi is changing, value of phi is changing, and what is the change in its value? That is delta S. And if we are moving in the PP dash direction, that is in the A direction, A cap direction, then rate of change of phi with respect to S will be delta phi by delta S, and which can be written. Note that these are not differentials, these are small quantities. Delta phi by delta n is equal to delta n by delta S. And from this relation, we know that delta n by delta S, that is equal to cos theta. So eventually we get delta phi delta S is equal to delta phi delta n into cos theta. Now if we consider the limit, these are small quantities, ratios of the small quantities, and if we consider the limit, we will get the derivative. That means as P dash tends to P along P dash P, then we will get the derivatives. Del phi del S is equal to cos theta del phi del n. Now from this relation, let us observe one thing. So what is the, since theta is a small angle, and and it can vary from 0 to a very small value, finite value, 0 to some finite value. And then in that range, what is the maximum value of cos theta? Maximum value of cos theta?
1.
1, sir.
It will be 1. And that will occur when theta is equal to, there is a typo. It will come. Okay. So this relation, so another. So from this relation, from this differential equation, rather we can note that maximum value of del phi del s, that means rate of change of phi in the direction, arbitrarily chosen direction A cap is equal to mod of del phi del n, the rate of change of phi in the normal direction. Okay, and that will occur when theta is equal to 0. Now let us go back to the picture once again. This picture, if phi is, if we are moving from p to p dash, if phi is decreasing, the value of this delta phi is negative, then del phi del s definitely will be negative. Okay, so del phi del s definitely will be negative, and if del phi is positive, then del phi del n will be negative. So this is our observation. And then if we consider this vector quantity del phi del n, this is a scalar quantity, and if we multiply it with this n cap, the unit vector in the normal direction, this completely specifies the maximum rate of change of phi together with its direction, and it is called the gradient of phi at p. Okay, so therefore, what is your gradient? Gradient is nothing but rate of change of phi in the normal direction. And if we multiply this unit vector with this quantity, scalar quantity del phi del n, we will get the maximum rate of change of phi together with its direction. Whether it is whether maximum rate of change is occurring in the outward direction or inward direction, that will be precisely determined by this vector quantity. Okay, and this is the definition of gradient of phi. So therefore, suppose a scalar field phi is given, then you take phi is given means within a region R of space, this function is uniquely defined, and through each point P in this region, a level surface, a unique level surface will pass. And now if we find the gradient at that point using this formula, later we will, from this definition, it is difficult to determine the vector del phi del n or the gradient. Okay, so therefore we need scalar equivalence, so which I will mention later on. But the vector del phi del n cap will give us a unit vector in the normal direction to the level surface passing through that point P. Okay, so this is very important, and we'll be using this in different problems. Okay, so therefore grad phi, this is its symbols. Gradient of phi is normally denoted by either by grad phi or this symbol. This is called nabla. This inverted triangle, it is called nabla phi. So it denotes the gradient of phi, and it is defined by del phi del n into n cap, rate of change of phi in the normal direction. Okay, so now it can be proved. So proof I have not shown over here. So grad phi is equal to del phi del x I cap plus del phi del y. There is a typo once again. Del phi del y j plus del phi del z k. It can be easily proved. So now you see, if a function phi is given, phi of x, y, z is given, we can immediately find its gradient at any point x, y, z. Okay, so once we determine this vector, it will have a magnitude as well as a direction, and then that magnitude of the vector grad phi will give us the maximum rate of change, and the direction will tell us in which direction that maximum rate of change is occurring.
Excuse me, sir.
Yes.
The second term will have del phi del y in it.
Yes,
instead of del
that
x.
is a typo. Yeah, let me. So I will correct it in the main text. It will be this del phi del y. Yeah. So this is the definition, and the physical interpretation is that at any point a level surface will pass in the scalar field, and del phi, a grad phi, will give us a normal vector at that point to the level surface. Not only that, it will also give us the magnitude of the maximum rate of change of phi. Well, so yeah, so now the directional derivative. Now what is del phi del s? Del phi del s is the rate of change of phi in the direction of pp dash, in the direction which makes angle theta with the normal direction. And del phi del s, from our previous derivation, we had found that it is cos theta into del phi del n. So this cos theta can be obtained by taking the dot product of a and n. A is taken in the pp dash direction. This is unit vector, and n cap is the unit vector in the normal direction. So therefore, you take this n cap with del phi del n, that will give you grad phi. So therefore, this del phi del s can be obtained by taking dot product of this unit vector in that direction, in the direction of pp dash, with this grad phi. And this is called the directional derivative of phi along and in the direction of a cap. And the operator. So this is very, very important operator, and you will encounter this operator in many places. So this vector operator I del del x plus j del del y plus k del del, once again there is a typo, k del del z, k del del z is and this is called directional differentiator. This is called vector differential operator. This delta, this nabla, basically this nabla is called the vector differential operator, and a dot nabla is called the directional differentiator. Okay, so a dot delta is called the directional differentiator. So can you mute yourself, please?
So
So
can you please repeat the directional derivative
okay,
part?
okay, I'm doing. So let me mute everyone.
Sir, data disable the mics for all.
No, no, sir. Don't do it.
Yeah, so if few of
Then
you
sir,
are talking, then I can communicate with you. I can respond you. And similar type of questions can come in your mind if the question is addressed.
yes,
Okay.
sir.
Then please don't ask it again. Okay. And if you have genuine question, please let me know. I will definitely repeat. Yeah, so directional derivative means rate of change of phi. If we look at the picture, means rate of change of phi in this direction, pp dash. And what is the unit vector in this direction? Unit vector in this direction is this grad phi. A unit vector in this direction is a. This is yeah. Oh, this is the unit vector in the direction pp dash. And rate of change of phi in this direction is del phi del s, because this pp dash, its magnitude is del s, and change of phi is del phi. And if you look at this relation, not this one, del phi del s is equal to cos theta del phi del n. And del phi del n, if we multiply it with the normal vector, we have defined that quantity, vector quantity, as gradient. So del phi del s is equal to cos theta del phi del s. And now we are interested to find del phi del s. Therefore, what we can do? So cos theta del phi del n, and this cos theta is nothing but dot product of a and n, unit vector a in the pp dash direction, and n is the unit vector in the normal direction. Therefore, both of them has unit magnitude. So 1 into cos theta. And now you include this.
नोट्स आप लोगों के लिए बना रखे हैं इंट्रोडक्शन टू एंड्रॉइड डेवलपमेंट तो एंड्रॉइड इज फॉर द कम होने वाला है नंबर बढ़ने ही वाला है ठीक है अब यहाँ पर हम लोग देखते हैं एन एक्सएमएल फाइल इज यूज्ड टू लेआउट्स इन
Please mute.
Yeah. This is the directional derivative. This n, if it is multiplied with del phi del n, it is grad phi. And grad phi, if you take the dot product of grad phi with a, you will get the directional derivative, that is del phi del s. And this operator, delta operator, or the nabla operator, is called the vector differential operator. And if you take the dot product of a unit vector in the specified direction in which we are trying to find the rate of change of phi, dot product of that vector with nabla is called the directional differentiator. Okay, so let us solve the problems. I think then
Sir,
much clear. Yeah. Yes.
Sir, in the formula of grad operator, why the equivalent sign is used? So nabla equivalent to.
Yeah, since this is an operator, this is standard practice, I would say. Okay, so this is nothing like value actually. This is the operator. Therefore, often in the literature, this symbol is used. Okay, nothing special about it. Is the operator. Okay, if it is the derivative of something, then we normally use the equality sign. Yeah, so as far as I know, this is the explanation.
Sir,
Okay, so
and what is the meaning of del x? It is partial differentiation with respect to what?
x with respect to x. Partial differentiation of the function on which this operator will operate. Okay, so let us solve the problem. I think it will be very clear. So I have the example. Yeah. So find the gradient.
Sir, why don't we keep arrow in the on top of nabla?
Arrow in some books, in most of the books, the arrow symbol is not used.
Sir?
Yes. Yes. Yeah, arrow is in general not used in the in most of the books. Okay, so therefore I have adopted this symbol nabla. And definitely this is a vector operator, and yeah, it performs derivative in a particular direction. Okay. Rate of change of some function in a particular direction. That task it does, but normally in different books, arrow symbol is not used. Okay, so I have adopted this one.
So it is written in bold letter. When we write it, we have to keep the arrow symbol now.
Not necessary. In book, it is not necessary. Nabla is quite yeah, common in use, so therefore you can use this nabla. And if you like, that is also not wrong actually. If you use the arrow symbol.
Sir, how del phi by del n converts to del phi by del x plus del phi by del y plus del phi by del
Okay, so
z?
that mathematical derivation I have omitted. So if you are interested, then I can provide you the material, or I can discuss it in a separate class. Okay, it can be derived actually.
Okay, sir.
Yes, sir. Please provide the material, sir.
Yeah, if you are interested, I can just add here the text.
Yes, sir.
In the main note. Okay.
Okay, sir.
Okay, I will do that if you are interested. Yeah, so now let us solve the first problem. The gradient of the function. Find the gradient of the function. This is a scalar. This defines a scalar field in R3, that is in space, and we have to find the gradient of it at the point 1, 0, 0. And we have to differentiate it in the direction specified by 2i minus 2j plus k. That means directional derivative we have to find at this point in this direction. And first of all, we have to find the gradient of it. So let me show you.
4ik plus 9k.
Oh, so you have done it already. Okay, very good.
Minus
so let's
3j
just
cap also.
Minus 3j cap, sir. 4i cap minus 3j cap plus
Minus 3j
9k
cap is also there.
Yes, sir.
this one, you mean?
Not along the direction,
Okay.
sir. Not along the normal it is.
So gradient. You mean you have already found the gradient. So let me solve for others. 2x square minus 3xy plus 9z. So the given function or scalar field is x, y, z. You tell me the equation. Yeah, function.
2x square minus 3xy
3xy
plus 9z minus 2.
Minus 2.
Yeah, we have to find the gradient of phi at the point 1, 0, 0. So grad of phi. Okay. If you like, you can put an arrow over here, or you may not like it. Write it. So this is also sufficient. So this is equal to, by definition, del phi del x at xyz. Note that at a general point, del phi del y plus k del phi zz. So this del phi del x is the partial derivative of phi with respect to x, del phi del y partial derivative of phi with respect to y, and then del phi del z is partial derivative of phi with respect to z. Then I into del phi del x is 4x, and I assume that all of you know partial derivative. So while differentiating with respect to x, we would assume that y and z are constants. Okay, y and z constants, plus j del phi del y, that is minus 3x, plus k del phi del z is equal to 9. And now this is del phi grad of phi at xyz. We have to find grad of phi 1, 0, 0 at this point. This is equal to 4i minus 3j plus 9k. 9k. Okay, so this is the gradient. Now we have to find the directional derivative in a particular direction. That means A is given. Okay, unit vector. So first of all, we have to find the A cap, that is unit vector along the given direction 2i minus 2j. So what is that? 2i minus 2j
3
plus k. Yeah. So plus k. So we have to first find the unit vector along is equal to 2i minus 2j plus k divided by root over 9. 4 plus 4 plus 1, that is 9. So 1/3 basically. And this is equal to your A cap, say, unit vector. So therefore, directional derivative, how it can be obtained? Directional derivative is given by A cap dot grad of phi. So you take the normal derivative and then you take the component of that normal derivative in the specified direction. That is 1/3 2i minus 2j plus k dot. So what is the gradient we have found? 4i minus 3j plus 9k. Right. So therefore 1/3, that is 8 plus 6 plus 9. So this is equal to 23/3. Note that this directional derivative is a scalar. On the other hand, gradient is a vector. Okay. So therefore, we are able to solve the problem, and next you try to solve the second problem. Find the equation of the tangent plane to the surface. To the surface, this 2xz square minus 3xy minus 4x is equal to 7 at this point. Note that this point is on the surface, on the given surface. So we have to find the equation of the tangent plane. So using the concept of gradient. Okay. So let us try this one. 2xz square minus 3xy minus 4x. That is the equal to 7. That is basically a level surface. No. So what is your given surface?
Sir, can you please show the question again?
Okay, just a minute, please.
Okay, so you are writing given something.
2x z square 2x z square minus 3xy minus 4x is equal to 7.
And the square is 7 at 1 minus 1. Okay, thank you.
Okay, at the point 1 minus 1 2. Okay, 2x z square minus 3xy minus 4x is 2x z square minus 4xy plus what?
So minus 3xy
Minus 3xy minus
plus
4x.
minus 4x.
3xy minus 4x equal to 7.
7.
And this is your level surface. This is number 1. Now you take, what is your scalar field then? Let you take y z, this is equal to 2x z square minus 3xy minus 4x. You take this level surface, and 1 is nothing but, you take this scalar field. 1 is a level surface of phi, or defined by phi, passing through 1 minus 1, what is that point? 1 minus
1
1.
minus 1, 2.
Minus 1, sir.
1 minus 1. Yeah. So basically the equation 1 represents a level surface passing through the point 1, 1, 2. Let us suppose this is the situation. Surface is something like this. You have this point. And now what is our task? Our task is to determine the tangent plane. Okay. Determine the tangent plane. Let me just draw this. And now how to draw, how to find the tangent plane? To write the equation of a plane, the standard thing is that to determine a normal vector.
Find the gradient.
Yeah, to find a normal vector.
सर नॉर्मल पता है पॉइंट पता है
So this normal vector we will determine, and it is given by the gradient. And now if you know the normal vector, you know a point 1 minus 1 2 on the surface, and any point xyz. If you take any point xyz, so and
That
if
will
you
be
add this, it will be
x
90
minus
degree.
x1.
Yeah, it will be 90 degree. Therefore, dot product of the gradient with this vector.
Will be
Let
0.
us suppose this is a AP. This is your P. AP will be equal to 0. So therefore, let us find the gradient of phi at. Let us find the gradient of phi first at the point xyz, and this is equal to what is your del phi? This is equal to I del phi del x plus j del phi del y plus k del phi del z, and this is equal to I del phi del x is equal to 2z square minus 3y minus 4 plus j into minus 3x plus k
is equal to 4xz. 4xz.
Okay, so this is at the point xyz, at a general point. Now we need to find it grad phi at the point 1 minus 1 2. Then we will get the normal vector. This is equal to I will put
7 minus 3 k plus 4 k.
7i.
Yes, sir.
Yes, sir, 7i cap.
1i minus 3j plus
3j cap
8k.
Plus 4 k.
8k cap.
7i, I think 7
Plus
or
3J.
what?
7i, sir. 7i minus 3j.
Minus
7
3j
minus 3j plus 8k.
Plus 8.
3j plus 8k. So this is, so therefore this is a normal vector to the plane. So therefore the tangent vector, a tangent plane at.
Sir, someone's mic is on, I think.
So can you please mute yourself? Okay, so please mute yourself. tangent plane at this.
Please mute.
Sir, I think you have to mute the person.
Yes, sir.
माइक में जा रहा है.
No, not this one. Is you have to take x minus 1 dot 7 plus y
Minus
plus
1
1 into minus 3
minus 1 minus
plus
3.
z
Minus 2 into
minus 2
minus 2
dot
into
8.
Okay, 8.
8.
8 is equal to 0. So I think this is clear because you have a plane.
Point and dr.
Yeah, you have this point 1 minus 1 2 and you have this normal vector given by grad phi. This normal vector is known and any point x, y, z. If this any point on the plane have the position vector ij x, y, z, then this vector AP is perpendicular to
Del phi.
grad phi.
Grad phi.
So therefore AP dot grad phi is equal to 0. And that we have used over here to determine that this is the required equation of the tangent plane. So this is one application. Now there are other problems as well. So you look at the third problem, in what direction from the point this is the directional derivative of this a maximum. So therefore basically you have to find the grad of phi. Okay, and then to tell the direction, probably you can find the unit vector in this direction and you can tell that in the direction of the unit vector, the rate of change of phi is uniform, a maximum. And what is the magnitude of this maximum? So you have to just take,
mod of.
Yeah, so you have to take the modulus of it.
Because cos theta is equals to 1 is the max.
Yeah. No, you may have negative value actually. Del phi
Yes, sir.
Yes, sir. Yes.
The magnitude. Okay. Yeah, so now the fourth problem a little bit different than the others. Find the angle between the surfaces
Yes,
this
Limit
and this
Z in
at the point this. Okay, so let us show you. Let me show you. So x square plus y square plus z.
Directional del phi, and then we can find
Del
the
phi-
del phi
Del phi 1
So
or del phi 2, sir.
Yes, you just find grad phi,
Yes, sir.
Yes, sir. And then we can find
at this point for then you have two vectors. You have
can
two
take
vectors and then you have to find the angle between two vectors. I think
Yes,
you
sir.
can solve it.
Sir,
Yes,
it
sir.
should be angle between the tangent, no?
Tangent or normal?
Tangent or normal. Here we will consider
Gradient.
the normal angle between.
Yeah, so
Can I
90.
tell the
So
answer of
find
question
the
number 2?
gradient. Please repeat.
Question number 2 answer.
Answer.
For two surfaces, we will find normal and sir.
Yes.
Sir, in the problem number 4, there will be the two gradient of the two equation x square plus y square plus z square equal to 9 and the z equal to x square plus y square minus 3 and this gradient equation is the angle between the two surfaces.
No, gradient. No, let me then show you. Probably I need to.
Can you show
number 3 also? Number 3.
Del phi 4 of del phi 2.
Achha, number 4, let me first solve it and then I will go to other problems. Find the angle between the surfaces x square plus y square plus z square equal to 9. So what is this? This is a surface, rather level surface passing through the point, level surface defined by the scalar field x square plus y square plus z square. Okay, so what is the underlying scalar field over here? x square plus y square plus z square. So let me show you how to solve the problem.
Theta is equal to 54.41 approx.
Yeah, so let me just check. Yeah, very good. Yeah, go ahead. So let us take phi 1. This is one level, one scalar field. This is equal to x square plus y square plus z square. And the given surface x square plus y square plus z square equal to 9 is a level surface of this defined by the scalar field through the point 2, 1, minus 2. And then you take phi 2 x, y, z. This is equal to z minus so what is this? Z minus x square minus y square, and that is equal to minus 3. It is also a level surface. Okay, that is defined by the phi 2. So you take this. Constant is not necessary to include in this
Plus y
scalar.
square.
Y or y square. So what is that? This is y square, I think.
Y square, sir, y square.
2 is equal to 4. Let me just check. It will be y, I think. Now, otherwise it will not be satisfied by
This
this.
is x square plus y square minus z na phi 2.
No, z minus x. Is this point lying on this surface?
Yes, sir.
Just
Yes,
check.
sir.
Yes, sir.
Yes, sir.
Yes,
Yes,
sir.
sir.
It's fine.
That is
4,
fine.
yeah. So then we can take phi 2 is equal to z minus x square minus y square. Okay. Yeah, so let us check this, and then you find gradient, and relevant point is 2, 1, minus 2. Correct me if I am wrong. 2, 1, minus 2. This is the relevant point, I think.
Sir, 2 minus 1.
2 minus 1, 2. Yeah. 2 minus 1, 2. Let me correct it. Minus 1, 2.
Why didn't we write the constant terms?
That will not make any difference because you see it will define. So if you take this phi, you can take it. Okay. So if you take this, and what is the surface given?
Constant
What is the
derivative.
surface given? Surface is your this y square plus z square equal to 9, right? And then this is basically what is this? X square plus y square equal plus z square equal to 9 is a level surface defined by this scalar field phi 1 at this point 2, minus 1, 2. Okay, so you check it. So what is your phi 1, 2, minus 1, 2? That is equal to 7. Okay, so there not 7, 9. That is equal to 9. So therefore, through this point, the level surface which will pass will have the value 9. So we are considering this level surface. And then you know this grad of phi is defined using the derivatives. If you take the constant or not, on that consideration, your grad phi will not change. So suppose you take minus 9 over here, but your grad phi will not change because this will have no contribution. So therefore we will try with the minimal thing. Okay, so that is my logic.
The constant.
So constant will have no effect actually in the gradient or in determining the
Because we are differentiating.
Yeah, we are differentiating. That is my point.
It will be 0.
Yeah, 2xi is 2xi plus 2yj plus 2zk. And your normal vector phi 1 at the given point 2, minus 1, 2. This is equal to 4i minus 2j
plus 4z.
4k. Okay. And this is normal to the, in fact, you have another surface. And what we are doing, we are taking a normal to this and this, and we are determining the angle between these two. This is our objective.
Okay, so now it is understandable.
Yeah. You have one surface. yeah, you have one surface, and on
Angle
the
between
one
two
surface
gradient.
we are no, not tangent vector.
Two
We are,
normals actually.
yeah. So suppose your
Between two
first,
gradient.
this is your surface 2, and this one is your surface 1, this spherical surface. Okay, and this is the point basically 2 minus 1 2. Now what we are doing, we are just finding the normal vector to the first surface. This is say n1 cap. It is given by the gradient, not n1 cap. Yeah, n1 cap we will determine. In fact, we can determine the normal vector, and the angle between the normal vectors will give us the angle between the surfaces at this point. Yeah.
Sir,
Yes.
the two level surfaces does not intersect. It is the condition of level surface. So how they can intersect?
Level surfaces defined by
It
a
is
single
different.
scalar field. Single scalar field. Here, two scalar fields are involved. Please, yeah, you have a look at it. Level surfaces associated with a single scalar field will never intersect, but you have different functions actually here. So therefore, they can intersect. Okay, so then unit vector not
What is N2
necessarily.
in this case?
N2 is the
So what is
unit
N2?
normal vector on the level surface 2. That is z equal to x square minus y square minus 3. So therefore, you now find grad of phi 2. This is equal to minus 2xi minus 2yj
YJ
plus k.
Minus k. Yeah.
No, plus k.
Yes, sir. Yes.
Minus 1 to.
Someone unmute.
So please mute that person.
mute my.
So please mute yourself. Otherwise, it will be difficult for me. Yeah. So please mute yourself. So I am trying to go very slow. So I think you can understand. And this is very, very important subject. Later on, you will need this concept, these concepts.
Someone is doing jubilation.
Sir, can you show sum number 3 one more time?
Just let me calculate this one. Minus 4i plus 2j plus k. So we have
Plus
not
2k.
these are not the unit normal vectors, but they are normal vectors. So therefore, what
Now
is
we
your
have
angle between the surfaces at the point? So basically, this is grad phi 1 dot grad phi 2 at those points, and then you have to take the modulus.
Phi 1, grad phi
Sir,
2.
cos theta.
Yeah,
Cos
yeah, cos theta. Very
Cos
good.
Inverse.
Grad phi 2. So then, if you just evaluate this, you will get the number. I think I can do it. Minus 16.
29.
16 minus 4 plus 4. I think this is correct, and root over 16 plus 16, 32 plus 4, 36, and then in the 4,
21.
16 plus 4.
21.
Yeah,
21.
this is the number.
21.
It will give you cos
4
theta,
by
and
21.
you can find the inverse function. You can
Root 21.
apply the inverse function to determine theta.
29 degrees something.
Sir.
this much.
So
Yes.
theta must be in means close to 0 and close to pi now. Because we already assume theta to be very.
No. So you are probably there in the formulation. What we are doing, we are considering level surfaces defined by a single scalar field. Okay, then we are taking.
Oh, okay.
Here two different scalar fields are important, and they will different their own level surfaces passing through different points. Okay.
29.1 degrees.
Okay.
Yeah.
Sir,
Hello.
theta is
Sir.
cos inverse.
Yeah.
Sir, can you give
Sir,
some more questions?
Level surfaces.
Yeah. So these other problems you try to solve. So there are 6 problems, and if you these are the representative problems, and if you
Number 3, sir, please solve number 3.
In what direction from the point this is the directional derivative is maximum. Okay, so this you just find grad phi.
Sir, we have to consider a unit vector.
Yeah, direction, whenever we are talking about direction, unit vector is a standard practice, but otherwise any vector in that direction is sufficient. Okay. Not necessarily it should be normalized. Okay.
Sir.
Yes.
Sir, once
Yes.
again repeat that
How will we find
intersection
the
of two
value of
level
unit
surfaces,
vector?
sir. You explained something about that two level surfaces intersection.
Yeah,
Someone asked
so
why it is intersection. Please explain that.
yeah, so you are probably mixing with this. Here, only one scalar field phi was involved in the derivation. Okay, so through any point, if you have a scalar field phi, through any point, a unique level surface will pass, which has been denoted by S. But if you have two different surfaces, two different functions or scalar fields, then through this same point, two level surfaces will pass. One is associated with the first function phi 1, let us say, and other one will be associated with the second function phi 2. Okay. Is it okay?
Okay, sir.
For you?
Yes, sir. Clear, sir.
Yeah, so that is the thing. Now, do we have some more time today? What is
Sir, in question number 3, actually I found the grad phi, but you know that direction, like I am not able to find. Grad phi is coming to be minus 4i minus 4j plus 12k, and that direction.
then direction is that vector only. That vector will give you the direction.
That vector only.
Or you can find
What
the
unit
unit vector.
vector?
You can find
Sir,
the
we
unit.
can
How will
see
we
that
find the unit
because the
vector?
cos theta will
Sir, how will
be
we find the
1
unit
at
vector?
that point of time. So the vector unit vector and the a cap vector actually coincides. So theta is 0. So that is the maximum directional derivative.
You are once again missing this theta. The a vector is user specified. Okay, but normal direction is not user specified. Normal direction is determined from the gradient. Okay, gradient
Yes,
will
sir.
always give you the normal direction. But the a vector, it depends on the choice of the point P. However, it may be close to P.
But that is what the question is asking. Na? It is asking the user defined vector in what direction from the point. So that will be equal to the
So in
normal
what
group.
direction?
Then no need to
Direction maximum rate of change occurs in the direction of the gradient. Okay,
yes, sir.
so therefore
Okay,
you
sir.
need
So
to find.
solve the question.
Yeah. Acha, so let me solve you. It will be quick. So x square y z cube. Yeah. So what is our scalar field here? X y z. X square y z cube. And gradient of phi at the point xyz is equal to 2xyz qy
minus 4j plus 12.
plus x square z cube j plus 3 x square yi z square k. And what is the point? Please tell me. 2
1 minus 1.
Minus 4 I cap. Minus 4 I cap.
Minus 4 I cap minus 4 j cap plus 12 k.
cap.
Minus 4 j cap.
Yes, sir.
Plus 12 k. Plus 12 k cap.
12 cap. Okay. Then what is asked in the problem? That you have to find the direction in which the directional derivative of phi is maximum. That means it is indicating the normal direction. So the required direction is given by this is equal to minus 4i. You can either write this vector or you can find the unit vector in this direction by dividing it with its modulus. 16 plus 16 plus 144. This is equal to 276. That means
176, sir.
176.
is it perfect square?
Not
or?
a perfect square.
Anyway, not necessary. 176.
No, sir.
Then 4i. This is minus 4i minus 4j plus 12k. So this is the direction in which maximum rate of change of phi will occur. That way you can answer. And what is the maximum rate of change? So what is the second part of the problem?
The magnitude.
Magnitude. Yeah, what is the maximum? What is the magnitude of this maximum? That is root over 176.
Sir, can you again show the last page?
This one.
Yes, sir. Sir, a minute.
Yes,
Sir,
please.
there
Yes.
is
Okay,
written
sir. Now
it is for
The
maximizing.
magnitude depends upon us, sir.
Magnitude depends on
Us means how much long we want to take the vector.
no your gradient. So what is said in the problem that del phi del n into n cap gives the maximum rate of change of phi together with its direction. So a strong statement is written in the definition. You look at it.
So now you can check.
Yeah, so you look at the definition. Thus, the vector quantity del phi del n into n cap completely specifies the maximum rate of change of phi together with its direction. Not only this will give you the maximum rate of change of phi, but it will also give you the direction in which the maximum rate of change of phi is occurring. And later we have found that del phi del n n cap is equal to this one, del phi del x I plus del phi del y j plus del phi del z k. So therefore, if it is asked to find the maximum direction of the maximum rate of change of phi, we have to simply either give this vector, calculate this vector, or the unit vector n cap. So both will give us the same maximum. Same direction actually, unit vector or the entire vector, it will have some magnitude, direction will not change. Okay, and the magnitude of this will give us the magnitude of the maximum rate of change. So that's what we have done here.
So what is magnitude? 1 or root 176?
No, let me write. So what is the magnitude of this maximum? So magnitude of this maximum is root over 176. Magnitude of this maximum, magnitude of the maximum, max is equal to magnitude of this grad phi at this point 2 1 minus 1, I think, and this is equal to root over 176. You have already seen. This completes the solution.
Sir, we can take common 4 from this minus 4 minus j and 12. Then there will be a difference in root under 176. Sir. If we take common in the simplest form, our direction.
4 root 11.
Then the
4
magnitude root
16 to 11 is 176. So 4 root 11.
Yeah, that you can do, no problem. 4 you can take common. Okay, so I think we can move on to vector integration. Do we have time today? No.
No, sir.
So we are running very slow anyway. So we'll make it. So in the next class tomorrow, we will start vector integration, particularly line integral. And today I will just make the minor corrections we have identified today in the note, and I upload in the MS Teams. Please, yes.
Please show sir question slide, sir.
I will upload it. Okay.
So can you give some more question to solve?
Yeah. So do you have this Spigel's book? Soft copy is available. You can download it. So many problems are there. Actually, you will get at least 50 problems.
Sir, can you write the name of the book?
It is given in.
So short problems are also there in the book.
What?
Solved problems.
Yeah, many solved problems are there, and in the exercise, so many problems are there. You can.
Okay, sir.
So nice collection of problems. You can get it from this book. So in the first page it is given itself. First page also. So this material is up to previous class. Material is already uploaded in Teams, and the additional part will also be uploaded today itself. Yes.
When we come to offline, can we access this book in library?
Yeah, in the library, so many copies are there. Not 950, but some copies are there.
Sir, when we are coming?
Yeah, so we are hopeful. So although I don't have concrete information, but up to second year, many students already returned in the campus. Okay, so for your case, I have no idea at this moment, but I am hopeful that very soon you will come back.
After
Hello, sir.
Good, sir.
Yes, yes.
Sir, there is a report that four page is coming in June.
What? Please repeat.
It is coming in June, said by IIT Kanpur.